Hi everybody, welcome to my channel again. This is Oliver. We're continuing with section 2.1. We're doing practice B today. Section 2.1 is about using integers and rational numbers and graphing them and comparing positive and integer and negative numbers. So let's start. So the first problem, graph the numbers on a number line, then order the numbers from least to greatest. So first we have 2. 2 is right there, -3 is right there, 0 is right there. So we graph the numbers on a number line, then order the numbers from least to greatest. We know that least is here and greatest are there. So it's -3, 0, 2. Number 2, -5. So this is 0, this is negative, this is -2, this is -6. So -5 is right there. This is -5. 7, this is for 6. 7 is right there. And then -8 is right there. It's -8. Okay, so order the numbers from least to greatest. It's going to be -8, -5, and then 7. Okay. Number 3, -9 right there, -12 right there, and 6 right there. So we order the numbers from least to greatest: -12, -9, and 6. Tell whether each number in the list is a whole number, an integer, or a rational number. So whole number, integer, or rational number. So whole numbers, we know 0, 1, 2, 3, all the way to plus infinity, so none. So we don't have any whole numbers here. Integers, we do have -3. And rational numbers, all 4. Okay, so it's -1.9, 3/4, 0.8, and -3. Then order the numbers from least to greatest. So least, we have 2 negative numbers. -3 is to the left of -1.9, so -3 is the least. Then it's -1.9. And then 3/4 is 0.75. So that comes first, going to the right side, right? So it's 3/4 and then 0.8. Because 3/4 is 0.75 and then 0.8. Okay, number 5, whole numbers. Whole numbers, we have just 0. Then integers, we have -2 and 0. And rational numbers, all 4. 1.3, -2, 1/2, and 0. If you have to order the numbers from least to greatest, it's going to be -2, and then it's 0, and then 1/2 is 0.5, so that comes first, and then 1.3. Number 6, whole numbers. 2.5 is not, -7/8 not, -0.5 no, and 1/3 no, so none. Integers, no, 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 and no, so no integers. And rational numbers, all 4. 0.5, -7/8, -0.5, 1/3. Okay. Then order the numbers from least to greatest. We have 2 negative numbers. -7/8, that's almost -1, so that one is going to come first. -7/8, then -0.5, and then 1/3 is 0.3333, so that comes next, and then 2.5. Okay. Number 7, for the given value of a, okay, find -a, so -a would be -10.2. And absolute value of a, so absolute value of a, 10.2, is 10.2. Okay. Number 8, a is minus 14, so minus, and then right here, minus a is minus, and then a is minus 14. So that's plus 14. And then absolute value of a, absolute value of minus 14 is 14, because absolute value of a positive or negative number is a positive number. Okay. And this we know that minus times minus is positive number. Okay. Or two negative numbers is a positive number. 9, a equals 1/2, so minus a is minus 1/2, and then absolute value of a is absolute value of 1/2 or 1/2. Okay, that was 9. Number 10, identify the hypothesis and conclusion. Hypothesis and conclusion of the conditional statement. Okay, so the conditional statement for 10, if a number is negative, then its opposite is positive. So number is negative, that's the hypothesis. Opposite is positive, that's the conclusion. Tell whether the statement is true or false. So if a number is negative, then its opposite is positive. This is true, right? So on a number line, we have the negative numbers. So if a number is negative, so let's say -3, then its opposite is a positive number. Yes, so this is true. Okay. Number 11, if a number is even, then its opposite is a whole number. Number is even, that's the hypothesis. Its opposite is a whole number, that's the conclusion. Tell whether the statement is true or false. If number is even, so even numbers 2, 4, 6, 8, right? Then its opposite of the opposites of 2, 4, 6, 8 is -2, -4, -6, -8. Those are not whole numbers, because whole numbers are 0, 1, 2, 3, and so forth. So this is false. This is false. Give a counterexample. If a number is even, so 2 is an even number, but its opposite is not a whole number, because its opposite is -2, and -2 is not a whole number. So that's the counterexample. Tell whether the statement is always, sometimes, or never true for any non-zero integer x. So non-zero integer x, so integers we know are -infinity all the way to -3, -2, -1, 0, 1, 2, 3, all the way to positive infinity. Those are the integer numbers. Non-zero, so non-zero, so only we have the negative numbers and the positive numbers integer, those, that is x. 3 over x is an integer, okay? So let's take one negative and one positive number. So x is -3, and then x is positive, so this would be -1, this would be 1. Is an integer? Yes. But what if we get 2? So if it's 2, then 3 over 2, that's 1.5. That's not an integer, right? Because that's a rational number. So this actually is sometimes. Sometimes. Okay. Number 13, absolute value of x plus 1 is a positive number. We know that absolute value of negative number or a positive number is a positive number. So we know that absolute value of x, this here is always going to be a positive number. So positive number plus 1 is always going to be a positive number. So this is always true. Number 14, 2x over x is 2. X and x can cancel out here. So 2 is 2. Yes, this is always true. Okay. Evaluate the expression when x equals -2.5. So this is minus, and then x is -2.5. So this is 2.5, because minus and minus is positive. Absolute value of negative or positive numbers is a positive number. So absolute value of -2.5 is 2.5, plus 3 is 5.5. So the answer for the 15 is 2.5. The answer for 16 is 5.5. Number 17, absolute value of -2.5 is positive 2.5, and then minus 4 is minus 1.5. This is basically 4 minus 2.5. It's 1.5, but the negative number, the negative symbol we write because 4 is greater than 2.5. So it's negative 1.5. That's the answer for 17. 18, stock market. The gains and losses of a stock for a week are shown in the table. Which day showed the greatest gain? Which day showed the greatest loss? All right, so we have the days: Monday, Tuesday, Wednesday, Thursday, Friday. We have the gains or the losses. Gains are positive, right? So we just have Monday. We have gain on Monday, and we have losses on Tuesday, Wednesday, Thursday, Friday. Okay. All right, so which day showed the greatest gain? Well, the greatest gain is Monday because that's the only positive number. So this is Monday. Which day showed the greatest loss? That's the most negative number. That's going to be this one right here. Why? Because if you look at the tens and the hundreds, the tens, if you look at the tens, it's all zeros, 0, 0, 0, 1 is here. So this is the greatest loss. It's going to be all the way to the left on the number line, minus 0.12. So Wednesday is the greatest, is the day with the greatest loss. Number 19, class enrollment. The table shows the growth in enrollment of the senior class at the high school between 1999 and 2004. Which year showed the greatest increase in class size? Okay, so we have the years: 1999, 2000, 2001, 2, 3, 4. The increase: 15, 22, minus 7, minus 12, 10, and 18. So 22 is the greatest increase in class size. So that was year 2000. So year 2000 showed the greatest increase in class size. Okay, because 22 is greater than 15, is greater than minus 7, is greater than minus 12, is greater than 10, is greater than 18. Then next question, which year showed the greatest decrease in class size? This is the least number, right? The smallest number, basically. It's minus 12. So 2012, year 2002, year 2002, this one right here. Because on a number line, that's going to be all the way to the left, minus 12. Okay, so that's all for today. If you'd like to see more videos, please like and subscribe to the channel. And I'll see you next time. Bye-bye.